Hey everyone. So far we have been talking about moles a lot. Last time we were seeing how concentration was related to the number of moles. Concentration indeed was the number of moles of the solute dissolved per 1 decimeter cube, or you can say 1000 centimeter cube of the solution. So far we have three completely distinct formulas to find the number of moles. We have three formulas which include mass of the substance divided by the atomic mass, or you can say divided by the molecular mass. The other formula is volume of a gas in centimeter cube divided by 24,000, or perhaps volume of the gas in decimeter cube divided by 24. And the third formula was concentration of a solution times volume of that solution divided by 1000. In today's video, we're going to be talking about a new thing, that is molar ratios, also known as stoichiometry. So we're going to be talking about molar ratios, aka stoichiometry. Here we're going to see how the number of moles of one substance is used to find out the number of moles of the other substance. For example, if we have a balanced equation between sulfur dioxide and oxygen gas, for example sulfur dioxide reacting with oxygen gas over here and gives us sulfur trioxide over here, 2 moles of sulfur trioxide. This is a balanced equation, so the number written before it would tell us the molar ratios. This number written over here tells us the number of moles used. For example, like right over here, it means 2 mole of sulfur dioxide react with 1 mole of oxygen gas to give us 2 mole sulfur trioxide gas. This is a fixed ratio from the equation. This is a fixed ratio, and it follows the pattern of direct proportionality. If the number of moles of reactant change, the product also changes within the same ratio, and we always use the fixed ratio to find the answer. Let's try few questions to see how we apply the ratio. We have a question over here that says find the number of moles of sulfur trioxide. So we are concerned with the number of moles of sulfur trioxide formed by 3 moles of oxygen. So we have over here oxygen mole is equals to 3 and sulfur trioxide mole is an unknown quantity over here. So we need a relationship between oxygen and sulfur trioxide. We know one thing, that when we have a relationship between oxygen and sulfur trioxide, they follow a fixed relationship, and that relationship is 1 mole of oxygen gives 2 moles of sulfur trioxide. Based on our question, we put the values of the question in denominator. So oxygen moles are 3 and sulfur trioxide moles are a question mark, so let's call it X. We use direct proportionality to find the moles of the unknown. So we get to know that 1 times X is equals to 2 times 3. X is equals to 6 moles of sulfur trioxide gas. We have our answer with respect to the relationship. Let's try another question. It says how many grams of sulfur dioxide. Now guys, focus. It's asking for the grams, not the moles. So how many grams of sulfur dioxide react with 46 centimeter cube of oxygen? There should have been a cube over here. I am putting a cube over here, yeah. So it's a relationship between sulfur dioxide, and it's asking for the mass of sulfur dioxide, and the data given is 46 centimeter cube. Obviously it's volume of the gas of oxygen over here. So we know one thing, that the data includes the gaseous volume of oxygen. We have to convert it into moles first. So it would be 3 steps. 1, 2, 3. Guys, hear me out. First, find out the moles of oxygen, because we always apply the ratios in moles. So we need the moles of oxygen. So we know that mole is equals to volume of the gas divided by 24,000, because it's gas over here. What is the volume? It's 4600 volume unit of gas divided by 24,000. So we divide this value by 24,000. 4600 should be divided by 24,000 and we get the volume. Perhaps the moles, sorry. The moles. So we get 0.1916. This is the mole of oxygen over here. Now, over here, we need to know the ratio between oxygen and sulfur dioxide. If we look at the equation, we get to know that relationship between oxygen and sulfur dioxide is, again, 1 times 2. The relationship between oxygen and sulfur dioxide is 1 times 2. Because oxygen has 1 moles and sulfur dioxide has 2 moles in the balanced equation. In the denominator, we put the moles from the question. So from the question we know that oxygen has a moles of 0.1916 and sulfur dioxide is something that we don't know. So we put a x over here. We apply the relationship very simply and we get to know that x is equals to 2 times 0.1916. So we multiply this value times 2 and we get to know that sulfur dioxide would be having 0.3833 moles. This is the moles of sulfur dioxide. And now we need to find the grams of sulfur dioxide. So we know there is a formula which says mole is equals to mass divided by mR. We have the moles of sulfur dioxide, which is 0.3833. We just calculated this value. We don't know the mass, but we do know the mR of sulfur dioxide, because sulfur dioxide's mR is going to be sulfur, which is 32, and oxygen is a 16 atomic mass times 2, because there are 2 oxygens over here. So 32 plus 16 times 2 gives us 64. So the molecular mass is 64 units. We get mass by multiplying 0.3833 times 64. We multiply this value by 64, we get the answer, which is 24.53 grams. So the mass is equals to 24.53 grams. Let's try out a past paper question to see, are we able to apply these ideas in actual past paper like question? We have a question over here. We have been given an equation and apparently there are a few past paper questions that follow. The question says, what mass of potassium chlorate, it's asking for the mass, so what mass of potassium chlorate is needed to produce 5 grams of potassium chloride? We have the mass of potassium chloride is equals to 5 gram, but we don't know the mass of potassium chlorate. So I'm going to put question mark over here. But we know one thing. We find the moles of the given quantity first. So we need the moles of KCl so that we can proceed further. It would be 5 divided by the mR. For potassium chloride, the mR should be equal to 39, which is potassium, plus 35.5, which is chlorine. So 39 plus 35.5 should be equal to 74.5 units. This is the molecular mass of KCl. We get the moles, we divide 5 divided by 74.5, 0.0671. This is the moles of KCl. Now we need a relationship between KCl and KClO3. If we look at the equation, we see the relationship between them is 2:2. The ratio is 2:2 between KCl and KClO3. So we simplify it and we get to know that the relationship is indeed 1:1. Now if the moles of KCl was found to be 0.0671, the moles of the unknown would be exactly the same because the relationship is 1:1. So we get the moles of KClO3 to be the same, which is 0.0671. This is the moles of KClO3. Now we know one thing, that the question did not want the moles of KClO3, it wanted the mass. How do we find the mass? We know that mass over molecular mass is equals to mole. Mass would be equal to moles times mR. If mole is equals to 0.0671, we have to find the mR and we have to multiply. So the mass would be equal to 0.0671 times the mR. Now what is the mR of KClO3? The mR should be equal to potassium, which is 39, chlorine, which is 35.5, and 3 oxygens are 16 times 3. So the molecular mass should be equal to 39 plus 35.5 plus 3 times 16, which is totally coming to be 122.5. So 122.5 is the mR. When we multiply this value by the moles, we get 0.0671 times the mR, 8.219 grams. So 8.219 grams. There are 3 distinct steps. In the first step, we find the number of moles from the data given. Then we apply the relationship between the two things. First, the one from which the data is given, and the other is the one which the question is asking about. And the third thing is, we finally find the mass or whatever quantity the question needs by using a very third formula, which is totally independent. In the next video, we will be solving similar questions, more questions from past papers, to enhance our understanding. So stay tuned, guys.